Of all the forces acting upon the surface of the Earth, earthquakes and volcanoes are the most dramatic and spectacular. In newsreel scenes, we can see the violence of Mount Vesuvius in eruption. The energy released here in one day is almost that of the first atom bomb. In 1944, a wall of lava from Mount Vesuvius descended upon the town of San Sebastiano. Sicily's Mount Etna is one of the most active volcanoes in the world. Eruptions have become major tourist attractions. However, lava flows such as this have threatened to burn several nearby villages. The destructive action of the volcano is like that of an earthquake. A major earthquake in Southern California caused much damage, particularly to this hospital. Earthquakes and volcanic eruptions frequently take place in the same parts of the Earth's surface. To understand why this is so, it is necessary to know how the Earth was formed. According to one theory, the Earth was once a ball of hot gases and molten material. For millions of years, this material boiled and bubbled. Gradually, it began to cool. As it cooled, the heaviest of the materials that make it up slowly moved to the center, and a thin crust of rock formed around the outside. The Earth, as it appears today, is the result of millions or billions of years of change. This is a diagram of the Earth as it might look if you sliced it in half. The Earth is made up of at least 3 different kinds of rock materials. In the center, there is a solid, very heavy iron and nickel core about 6,400 kilometers across. Around this core, there is a thick layer of heavy rock, the mantle, about 3,200 kilometers thick. On top of this heavy rock is the very thin and very light crust upon which we live. This crust varies in thickness from 11 to 50 kilometers. Scientists believe that the Earth's crust is divided into large sections which float on the mantle. These sections are called plates. In some places, the plates move, and when they separate, new material from the mantle fills in the gap. When the material from the mantle cools, it becomes part of the Earth's crust. In other places, one plate overrides the other and pushes it down into the Earth's mantle. The black lines in this map show where scientists believe the Earth's crust is divided into plates. We'll use modeling clay to represent the Earth's crust and simulate its movement. Tremendous forces and pressures acting upon the crust may throw it up into folds like this. In this way, perhaps, mountains are formed. As this folding occurs, cracks appear in the rocky crust, sometimes breaking it down into huge blocks. Where blocks of earth move along these cracks, the cracks are called faults. Here is a diagram of the Earth's light crust and underlying heavy rock. In this diagram, the black broken line represents a crack or fault in the earth. Over thousands of years, the mountain on the right is worn down. The weathered materials of its slopes are carried away by wind and water to be deposited, layer upon layer, in the lower neighboring basin on the left. The block of earth from which material has been worn away loses weight, and the block on which material has been deposited gains weight. When the difference in weight between them becomes great enough, they move in opposite directions. The block on the right moves up. The one on the left moves down. They slip along a crack or fault. The movement of these huge blocks of earth crust causes earthquakes. Because of the release of pressure under the block that moves up, a pool or reservoir of melted rock may form deep below the surface. If this melted rock is near a fault or weak spot in the crust, it may be squeezed or forced out onto the surface. We call this a volcanic eruption. Here is an active volcano in the Hawaiian Islands. Escaping gases hurl melted rock or lava high into the air. This is called a spatter cone. The temperature of this molten rock is greater than 1,000 degrees Celsius. The rock bubbles and boils as it oozes from volcanic vents. Flowing lava destroys everything in its path. Grass and wood are set on fire by the lava. The hot liquid flows like a river at speeds up to 50 kilometers per hour, carrying everything in its path. The river of white-hot rock cuts its own bed as it races downhill. As hot lava streams into a cold area, it produces great billowing clouds of steam. Many active volcanoes are found lining the Great Basin of the Pacific, forming a great circle of fire. Active volcanoes are also found along the mountainous edges of many continents. and on islands and mountains building from the floor of the world's oceans. We know that these regions mark places where the giant plates that make up the Earth's surface collide and fold as they move on the thin crust. A giant ridge in the Atlantic marks a line where the Earth's surface is moving outward on each side. It is along these lines that much of today's volcanic action takes place. Earthquakes are the results of movements of great blocks of earth crust along the faults. The resulting release of pressure may cause the underlying rock to melt. If this is near a fault or weak spot in the crust, it may be forced out to cause a volcanic eruption. Such action often takes place where the Earth's crust is weakened by the collision of the surface plates. Both earthquakes and volcanoes are evidence of the same forces, the forces constantly at work changing the face of the Earth.